A few chapters deeper into humanity's exploration of the cosmos, the great golden mirrors of the James Webb Space Telescope slowly unfold in the darkness nearly 1 million miles from Earth. Hidden behind its enormous shield against the sun's heat, the observatory drifts silently through space, turning its instruments toward the oldest light in existence. It does not simply observe distant objects. It looks backward through time itself. Every faint photon collected by the telescope has traveled across billions of years. Some began their journey before Earth existed, before the sun was born, when the universe itself was still young and unstable. These ancient rays carry hidden records of cosmic history, preserved within the colors of their light. During one extraordinary observation, the telescope focused on a remote galaxy known as JWST 140, whose light reaches us from less than 300 million years after the birth of the universe. In cosmic terms, this was the dawn of existence itself. Yet what astronomers discovered there was deeply unexpected. Despite existing so early in time, the galaxy appeared surprisingly mature. Packed into its compact structure was an enormous concentration of matter and intense bursts of star formation. Young stars ignited across the galaxy almost simultaneously, flooding space with powerful radiation. But the greatest surprise was hidden inside its spectrum. When scientists analyzed the galaxy's light, they detected traces of oxygen. That discovery changed everything. In the beginning, the universe contained mostly hydrogen and helium. Heavier elements such as oxygen, carbon, and nitrogen did not yet exist. They could only be forged inside stars and scattered into space after those stars died in violent supernova explosions. The presence of oxygen inside such an ancient galaxy meant that entire generations of stars had already formed and died astonishingly quickly. The young universe, it seems, evolved far faster than scientists once imagined. Instead of slowly developing over billions of years, early galaxies may have entered explosive cycles of star birth almost immediately after the first structures emerged. Massive stars formed rapidly, burned intensely, and detonated in colossal explosions, enriching space with heavier elements. Those elements seeded the next generation of stars. And from those stars would eventually come planets, atmospheres, oceans, and perhaps life itself. In that distant galaxy, astronomers may be witnessing one of the first great factories of cosmic chemistry, where the ingredients for future worlds were already being created near the beginning of time. But the telescope's discoveries did not end there. As Webb continued to peer deeper into the universe, astronomers found evidence that some early galaxies already contained enormous black holes growing at incredible speeds. According to existing theories, such structures should have required far more time to develop. Yet there they were, appearing shockingly early in cosmic history. Galaxies collided, merged, and transformed in violent bursts of activity. Enormous clouds of gas collapsed under gravity, triggering waves of star formation powerful enough to outshine entire galaxies. The early universe was not calm. It was restless, unstable, and intensely active. The deeper Webb looks into space, the more it challenges long-standing ideas about how the cosmos evolved. Instead of a slow and orderly process, the birth of the universe may have been a chaotic era of rapid growth, violent interactions, and unimaginable energy. And hidden within that chaos was the beginning of everything we know today. After exploring the ancient universe, the James Webb Space Telescope turned its gaze towards stranger and more mysterious objects closer to home. One of them was a faint drifting body known as a brown dwarf. Brown dwarfs occupy a strange middle ground between planets and stars. They are too massive to be planets, yet too small to sustain the nuclear fusion that powers true stars. For decades, scientists believed these objects were relatively simple and inactive. But Webb revealed something far more extraordinary. Inside the brown dwarf's thick atmosphere, astronomers detected methane, water vapor, and complex molecules swirling through dense layers of gas. Violent storms appeared to ripple across its surface, producing dramatic variations in brightness. Even more mysterious were glowing structures high above its atmosphere. The patterns resembled auroras, similar to Earth's northern lights. These ghostly emissions hinted at intense magnetic activity, possibly caused by an unseen moon interacting with the dwarf's magnetic field. If true, it would mean astronomers had indirectly detected a hidden world not by seeing it directly, but by observing the disturbances it created. Webb then shifted its attention toward distant planetary systems orbiting faraway stars. Around the star 14 Hercules, astronomers observed a massive exoplanet moving along a highly unusual orbit. Unlike the nearly circular paths followed by planets in our solar system, this world travels in a stretched and tilted trajectory shaped by ancient gravitational chaos. Perhaps another giant planet once passed dangerously close. Perhaps a companion star disrupted the system long ago. Or perhaps an object wandering through interstellar space violently disturbed the planets during their formation. Whatever happened there, the result is a planetary system far more unstable than scientists once expected. In another region of space, Webb observed an even darker fate unfolding. A giant gas planet, similar to Jupiter, is slowly spiraling toward its parent star. With every orbit, gravitational forces drag the planet closer. Immense tidal stress stretches and overheats its atmosphere. Over time, those forces will become catastrophic, tearing away the planet's outer layers and sending rivers of glowing gas falling into the star. Eventually, the planet will be completely destroyed. Observations like these reveal a deeper truth about the cosmos. Planets are not permanent. Some worlds collide violently with neighboring planets. Others are ejected into interstellar darkness forever. Some are frozen, shattered, or consumed by the stars they orbit. The universe is constantly changing. And yet, within that destruction lies creation. Across distant star systems, Webb has also discovered enormous rings of icy debris surrounding young stars. Inside those chaotic disks, fragments of rock and ice slowly collide and merge under gravity. Over millions of years, some of those fragments may become entirely new planets. Others will be destroyed before they ever fully form. But from this endless cycle of collapse and rebirth, new worlds continue to emerge. The same cosmic forces that destroy planets also forge the elements needed for life. The same stellar explosions that scatter devastation across space also create oxygen, carbon, and iron, the very materials that make Earth possible. Every atom in the human body was once forged inside ancient stars that died billions of years ago. In this way, destruction and creation are not opposites. They are partners in an endless cosmic cycle stretching across the universe itself. As the telescope continues its silent mission through space, it gathers more ancient light from the farthest corners of existence. Every new observation adds another piece to humanity's understanding of where we came from and how the universe became what it is today. Some discoveries will confirm what scientists already believe. Others may completely transform our understanding of reality. But with every photon captured, humanity moves one step closer to understanding the vast and mysterious cosmos we inhabit, a universe still unfolding its story billions of years after its fiery beginning.